One of the things that we can do is we can measure what the temporary droop adjustment or the temporary proportional gain is, which is in the dash pot when the large plunger moves, the small plunger recenters the relay valve. Well, there was a step change given this unit, and we're looking at the gate position. You see this little part of the movement there? That's the proportional gain. That's how far. It's about, I don't know, 77 and a half, about 2.5%. Move, the proportional gain would be 2.5. The reciprocal of that, and I didn't bring my calculator. Yeah. Take 1 divided by 2.5. 40?
2.5?
Yeah. 40%, right?
Yeah.
Okay. On a Woodward unit, that would be maximum on the slider, which is right here on a Woodward unit. This is that calibrated dial, which you'll see when you're probably going to see that test, okay? On the Pelton unit, it's that slider here. This is your temporary droop adjustment, okay? So one of the things we can do is I'm gonna close the dash pot needle all the way. I'm gonna take us offline gains. Now if we come over here in the front, I'm gonna give it a step change. And you never know if it's gonna work or not because we haven't done this, but I'm gonna give this a speed adjustment change. And what I expect to see is the gates to make a movement and stop. And that'll tell us how much proportional gain we have on the unit, okay? So somebody else is going to have to help me watch, okay? Did you see it move up there and stop?
Yeah. And
okay.
Then it come right back.
Well, that's okay. That's the compensation.
Right.
But I want to know how far it moved.
About 3 notches.
That'd be 3%. We'll get her back down and get her settled out here. I forgot. I remember I got that dash pot needle closed. Okay. So it's pretty close. So now, okay. I'm at 9%, okay? Somebody watch real close.
12.
So it moved 3%. 1 divided by 3 is 33 1/3. Your temporary droop on this unit's 33 1/3%. So now I know how much gain I got for temporary gain, okay? Now, because I've done the work for you, if I put that dash pot at a half a turn, it's got 7-second timing. And if I put it at a quarter of a turn, it's 10 seconds. A quarter is, on this unit, a quarter is 7, a half, I'm sorry, quarter is 10, half is 7.
Yeah.
So now you've got everything you need to know about this unit. You know, with proportional gain and the, you know, KP, which you'd call temporary droop and dash pot reset time. So now, the other thing we can do is I want to get this unit back at 98% and might go open the dash pot to a half a turn, please. I don't have any paper. You got any paper?
I do.
Okay.
Go ahead.
What we're going to do Thank you. To measure the time constant, and we'll see how close we come. The permanent droop plus the temporary droop divided by the permanent droop times the dash pot reset time is equal to the time constant of the governor. It takes 5 of those to get where we're going. So we've got 5% temporary droop, right? And we just measured this thing and we know we got 33% temporary droop and 0.05 times 7. So I've got 0.38, 0.05, that's approximately 7.2 times 7, about 49 seconds, right? So let's find out one time constant. So what we're going to do, I have to get to 30% gate, and I want to see how long it's going to take to get there, okay? I'm going to give it one shot. It's going to take approximately about 3 to 4 minutes to get all the way there.
This is your...
To get, I went from 10, I gave it 1% change. The gates have to move 20%. So they got to move from 10 to 30. Now, it wouldn't make any difference if I change this a half a turn, 1 turn, or 5 turns. It's going to take the same amount of time to get where it's going, okay? See, we're... You can calculate that.
It does 66%, then it does 66% of what's left.
62.8.
62.8, and then 62.8 of what's left at 62. So in theory, you can't
It never
get there
gets
from
there.
Here. Okay.
It's kind of like there was the old professor and an engineer there. And there was a naked lady on one end of the wall, and they were on this end. And the guy said, the rules are this. You can go halfway each time you make a movement. And the old professor says, like, Mike, we're never going to get there. The engineer says, yes, but we'll get close enough.
We'll get close enough.
Get close enough. So see, we ain't, it's not, now this is what we're talking about. Why do we have a dash pot bypass on there? Because what happened in the old days, when I make the first movement, the operator looked over and he thought the unit was where it should be. And then he turned around and he come back 5 minutes later, he says, the damn unit's drifting. It's drifting. So
See, on a mechanical, it takes, and depending on gate timing, it can take up to 10 minutes on an impulse turbine to make a change. Like on Francis, usually 5 minutes or so will do it. But I've seen them from 5 to 7 minutes. We've timed them.
you see, we're still
Still not there yet.
and it's going to be like
So if that guy's giving it a set point,
I think 4.5, 5 minutes. But see, we can calculate all that stuff.
So that's without the dash pot bypass.
That's without the bypass. I'm going to take it back with the bypass. See, but I just wanted to show you we
The
can
only other way you can get there is to
use the gate limit.
gate limit to go all the way up, and then as it
Yeah.
approaches, then
Yeah, we're going to show it, but see, they do that in the digital governor.
well, that's what we do when we're calibrating.
And they feed forward. They call it feed forward. So, but everybody see what I was talking about? But the thing I wanted to show you, you can calculate all that stuff. So then we know if the unit's working the way it should. We know this unit's working the way it should because it came out to be pretty close to our calculation. Now, we don't know how much that other needle's open, but you can play with that when you do the other part. I'm going to go back to the dash pot bypass, and I'm going to put 1 turn in there and watch the difference in response. So that's
I think we're going to find that other needle is way too open on this unit.
But change it. Show them.
Yeah. Well, I want to get a piece of key stock that they can, they can preset it in the field.
Yeah, but I mean, you can adjust it now. Just go.
Well,
in
I
there.
can just by watching it.
Yeah.
Because you can't, you really can't see how
Make
much
an
the
adjustment
coils.
to show that it changes. Just make an adjustment. We don't care what it is.
Okay. Try that.
Okay, now he's made a change, so I'm going to take it. Now that's more what I would expect to see in the field, something that fast.
Yeah, that was over a half a turn down farther than it should. That's what it acted like to me, that it was way open too far.
See, now with this, then I would be pretty well convinced that if I got separated from the system, although I'm loading faster now than I was before, I would still be stable. Okay.
For a frequency upset.
So, we're supposed to give you a demonstration, and I think we've demonstrated most things. Okay, what happens if I take the droop here to 0 now? What's going to happen? Which direction will the gates move if I take the droop to 0? So, you guys have been paying attention. And they will. Now, what happens if I have the droop at 5% and we got the gates exactly at 50%? Okay.
It's going to go to 50%.
In theory?
Well, technically, I'm at the pivot point of the, if everything life was perfect, and I get to 50%, it would be right on the
But it's not. I
balance
tried
point.
it yesterday.
That was because of that.
We're off a little bit on it. Yeah.
Speed.
Yeah. So right now,
I had a gentleman do that, giving the vice president a tour, and he says, "Well, what does this do?" And the unit was online, and he goes, "Nothing." He went like that and loaded that baby wide open.
I don't know if you were here yesterday when we came over. We were doing something, and Roger Clark said, "Hey, you guys can go over to the plant. You can touch anything you want to. It doesn't matter." And so I'm over here yesterday, and a guy comes up and started to pump.
In manual,
So I told Roger last night, I said, "Don't tell them they can touch anything." I was with, I think I was in Boston, Massachusetts. And we used to take, when I worked at Woodward's, we'd take the road show on it, we called it. And the manager says to the audience, he says, "You guys can do anything you want to these digital governors. They're bulletproof." So part of the package was an HMI, and it happened to be an Apple computer that was programmed. And so one smart-ass guy used to work at Stone and Webster. He was Chelan Power Company, and he had a run-in with the manager. So he goes over to the computer, Format C, said, "Don't work anymore." And I came over and I said, "Well, what'd you do?" "I formatted the C because Durrell said you could do anything you wanted to this thing. I just wanted to see if it worked." So I got to get on the phone, call back to Denver and say, "Hey, send me I got to reboot this thing and we don't have a disk." So you have to be careful when you say you touch anything. Okay, so we know how to time the unit. This unit looks pretty good. I'm going to leave them in your hands.
Yeah, and for the before lunch and everything, I was just going to show you guys different things on the unit. We can play with it a little bit,
Well, it's
and then
gonna
we'll get
take
into
a
calibration,
calibration.
hands-on after lunch.
Okay.
Okay.
What do you want on the computer?
I need the calibration. Thought we'd go through a little bit in the components. We're going to get this again during the hands-on. Is you hearing it? Did Jerry go through the pilot valve at all in the cage?
Yeah, a little bit.
Talk about
Not
a lot.
All right. Well, okay. You know where the dither is.
He explained it to us. 'Cause
Okay.
I
Well,
never knew
I know
that.
lots of people have
I
never
never
seen
knew
it.
that.
Never adjusted it. All right.
Never have them.
Hey, if you've got a little dither on it, it's fine. I've seen him. I said, "Well, do you adjust that?" And he goes, "Well, there's not. This isn't a Woodward." He says, "There's none on it." Yeah, there is.
So you
And that's what it is. There's a there will be a
No, that's a set screw.
there'll be a set screw. You take it out and then you loosen up the other one. Go in your hole with a paper clip will work. Okay, and you go through, and then you just snug up a little bit on it.
To where you can
Pull the paper clip back out, and then naturally you're going to lose a little when you
jam it.
jam it, okay? But it's going to be in the vicinity. And all it does is a once per revolution squirt of oil, and it causes that relay valve to jump. This one here is, oh, you see it?
You can feel it. You stick your finger on those speed nuts, you can feel it down
Yeah, if it's set right, you can see it.
unless you're over that bipolar.
Then you get triple trifocals. You guys need to invest in Noga bases.
And I'm not getting all of it there.
Right. SWAT usually like 2,000 to 3,000.
You can get 10, 7.
That's 4,000. You only get 3,000 or 4,000 travel one direction.
Yeah. Total up and down should be somewhere around, on a Woodward it's 7 to 10. On these I've seen some of them really vibrate. Sometimes the guys took those out and lost those screws. Okay? And didn't know it for years.
Right.
But when I walked out to the unit, this was going about 45 thousandths. Which is going to make your pumps run more and cost you more money.
I've had, before we did calibration on all 8 of our units, you walk from one unit to another, and those nuts wouldn't be equal on each side. Actually, unit 3, the nuts were almost touching the casting on the clothes.
Well, a lot of times you'll see it limited on the open because some of them have a PRV on them, and the movement would pop the PRV open on some of the models like Newport News, Alice Chalmers. It would pop them open, then they'd have to dispatch an operator to close it again, so they slowed down the opening, which it'll still load the megawatts per minute. You know what he did there? He just turned off, when he synced it, somebody dropped a big tin can and shut the lights off like it was, something went wrong. But you guys, have you been over most of the components on this? On what they are? The only thing different than on a Woodward is you've actually got an adjustable relay restoring on the gate limit.
Yeah, and then we have the speeder nut. Instead of the cam there, they're 22 degrees on the
That's right here.
speed adjust right there. Yeah, we have the speed nut.
I haven't seen that personally on a Pelton. Mine are it's either square like this or it just has that little, it's just a little oblong pointer.
Right, ours is actually, you have the...
And when a unit loads, it goes down. Okay, as the unit loads, this will swing down.
The speed adjustments.
Yeah, and it's really easy because it's just a thumb screw. You just take and turn it either or. It doesn't even have a lock on it.
Right.
Yeah, normally if I'm going to change this, I have to uncouple the speeder rod in the front, run it back, and then repin it. You can really understand why they call this a thumper. Get up here
Well, you can hear it.
well, yeah, but you can really feel it
there.
as it makes that revolution. It gives that squirt of oil.
See, that's something else we don't have is this dial back here, this little Selson motor. That'd be on the speed adjust. We don't have that. That just is linkage, and then we have a Bodine motor because it was built in the 70s.
Well, you have that linkage in this little rod
Yeah,
and everything, huh?
no, well, yeah, we have the linkage coming from the speed adjust, but it ties into the Selson motor or the Bodine motor.
Yeah, we don't have the motor hooked up here.
Okay.
Okay, but everything else should be the same on yours. You
Except
have
for
the
that,
universe.
we don't have that dial right there. The black thing on the side there where the linkage comes through.
You don't have
we
those
don't-
universals on there coming over to here?
No. Can I step on this?
Yeah.
We don't have this piece right
Oh, I got you.
That must be earlier.
I've never seen one on there except this one.
Oh, really?
Yeah.
Okay.
So, see, you got to realize this is a converted Pelton electric,
Right.
and we converted it back to mechanical, so it's still
Right.
got some parts on it that are.
Random stuff.
Yeah. Oh, it had a whole bunch of garbage on it. You were here. It had all kinds of stuff on it. We stripped off. This is a new duplex set up here. You know, these distributing valves are the same as a Woodward. A lot of the Pelton distributing valves, relay valves, are pretty small. They look, some of them are only as big as an aux valve. Depending on type of unit and how much stroke it's got, it may not need much. It's got, what's the stroke? And the size of the servos.
Oh yeah.
You know, that's the difference.
Our servos are pistons probably this big.
Oh yeah, see that takes a lot of oil moving, so it's got to have a big valve.
3.5 foot stroke.
3.5 foot? Wow.
For our wicket gate ring. It's probably, that's stroking about 3.5 feet.
Well, the stroke is always proportional to your sheave, okay? See the center line of that sheave right there? See that, the center of it, where it has a key in it? Well, if you go to the center of that rod, out to where the wire lies, is the stroke of the unit it's on. So that'll tell you where your stroke is. And it's got a little bit of play either way that you take out with eccentrics when you calibrate it. I've never seen one 3.5 feet.
That's, I'm talking how much the servo piston moves.
That's what I mean. That's stroke. If the servo's moving 3.5.
We got our servo blocks are, yeah, maybe 3 feet. I never really measured it, but it's, I put the lock.
Yeah, 24 is like the biggest one the TVA has. 24 inches.
We're 32 right now.
Are you? Got a lot of water running down the creek there, huh? What's cubic feet a second?
86,000.
Wow. Yeah, it's a big unit. That's big.
We've only got a 80-foot head, but we flow 86,000 on all 8 units.
And it's a Francis turbine. It's not a Kaplan.
It's Francis, yeah.
Low head.
Yeah.
Cavitation repair.
And you're the one that has you have Pelton horizontal IMOs, huh?
Right.
Instead of these verticals. The other components on here, did Jerry go through many of the components?
No, not so much.
Ball head, the motor's down here. Ball head's in here. Everybody always asks me, how come Pelton's got a glass on there? That's because it's slinging oil. It's got to. Hand me that, where's that ball head?
Capacity.
This one,
Our oil capacity is 2,100.
Oh.
snake would have bit you.
Servos.
I mean, that's a heck of a lot of different than a Woodward, okay? We may, if we have time today, take the top end off this unit. And they built this, and they said that I can align.
That's for one.
Well, I want to make sure it works before I haul it off. And it's got to go, this has got to be out of there to go down and through this. And what this does is you watch this. So this is rotating. okay, at the speed of the ball head, which is around 600 RPM.
And this is your stationary piece.
And that's what this is stationary piece, and then it recenters through this relay restoring every time that speed goes up or comes down. And I've seen these vary. I've taken 3 of them that are supposed to be the same, and there's 10,000 difference in everything. Yeah. The main thing is keeping them clean on the outside, you know. Clean them up. And clean oil is key to every governor.
We just did a big upgrade on our oil systems on the sumps. We put those CC Jensens. We put those big pleat paper. They're like a organic filter.
Oh, for a filter press setup?
Well,
Is it in a canister?
yeah, but it's about, I don't know, it's probably about that tall.
And they stack together? Yeah. Kunos?
Jensen.
They're Jensen, but same, it sounds like a Kuno filter. Has big wafer. This, the only, it's really different is it has, the limit actually has relay restoring. You got 2, okay? So you got 10, 20, 30, 40. This one here, you got 10, 20, 30, 40. So I would say this is, when you write down what was the relay restoring set, that's 20 to 1. Gate limit's 40 to 1. Have you guys had a problem ever with hunting on your Pelton units after you've taken the dash pot off and refilled it? You have to sit here and hold this bypass down, and I mean, when not on line, I'm moving it all over right now, and you have to push hard and keep this open and just keep doing that till you get that air out of there. It will not function at all. That thing, and it'll be one of those hunts that you'll say, oh good, I've got it, and then all of a sudden it'll hunt.
Yeah, it's not constant.
It's because I think what it does on a Pelton is that little bit of air that's on the other side, it finally makes its way over there, and that bubble gets up there and it hunts for a second, and then it'll straighten itself out.
I seen one time, the unit was hunting and someone had forgotten to tighten the lock nut on the valve.
Okay.
I didn't know it till I went to adjust it.
When you talk about these dash pot bypasses on a Pelton, I took it about over half a turn out. I measured this at one time. I believe I said it was like 3/16 or 7/64 is what that pops up. So I just took a piece of key stock to preliminary set this, but I set these to where it's got, when it's offline, I go ahead and jumper this out and pick it up. I've got good, I can take and run it down with a limit and see my 1.5 cycles real good on this one. Then I energize this, and I take this until I start seeing it hunt just a little bit, and then I just take it down to where it's just where it's not hunting. And then it has plenty of gain for online gains. Because all this is supposed to do is take away the same amount this is open. I'm sure they had this one set that way so they could show the action better, And you got to realize that this is dummied in speed, so it's not what you're going to see when you calibrate. You calibrate yours all in the dry, right? Do you get to run it
With the simulator.
just with the 3 stack out of Denver? It's a big.
No, your guys.
Oh, you got one of those?
Yeah. we got
Okay,
one of yours.
because I've seen the one come out of Denver. I did a couple classes in Wyoming, Glendo and Boyston, and they had a guy that came out, and they did all theirs. It was a traveling crew that I was training, and they never had seen the units run because they had like 6 months outages. They just delivered water down the Wind River at Boyston, and Glendo they just drained the lake at the end, and then they shut it down. To me, I'd hate to see that if I was working on a governor and I didn't get a chance to run it afterwards. I have a bad feeling.
One thing I noticed, you guys were talking about breaker signals, like shutdown solenoid, the 33 switches. I thought that was just something, but those numbers are pretty constant for Pelton.
Yeah, because they tied into all of those.
43 is our auxiliaries.
Yeah, they kind of match the industry. Okay,
I didn't
like a 12X, you know, everything. An 86 is a complete shutdown. You know, a lockout relay. All right, so when they say you're 86'd out of a bar, can't go back. You know, most of your Bs, you know, it's got these gate limits and everything out here. On your Bs, you got to open the front door, take the knobs off, and open the front door, and they're behind there, little cams. Okay. This one's made to swing open. I've just never had it open.
Take that one bolt out.
Yeah.
We always swing our door open when we're doing all our.
Yeah, I just take the knobs off because it's the only way on most of them. It's the only way you can get to all the limits.
Right.
They're just little stack of cams in there.
Right, and then the auxiliary valve. When you have to do those calibrations through the auxiliary valve, it's easier because you can get to those front shafts or that linkage, the vertical linkage up front. It's easier to get to those too.
Yeah. Depending on the head that's on it. Some of them go clear down, where you can't get underneath it.
Right.
This one's got room, and also, you know, this is the things that are at 50%. They're flat and level. Is this I call it the T-bar on a Pelton. Okay, that's level at 50%. This is level at 50%. This is normally level. Some other stuff isn't. Okay. And you saw you see where the droop is, huh? The little droop in-kind plane it's got underneath it. Seen a problem on one of those where it got so gummy that it wasn't touching the roller wasn't touching.
We got to the point, you know how those have clutches on the Bodine motor. Well, we do it bi-weekly, so we grease all our linkage and grease the greasers, and then put like white oil on the rollers and all the pins and everything for doing all that. Well, they were putting the white oil on the gears, on the brass gears. Well, it kept running down and getting in that friction. So the Bodine motor
Clutch slip.
Yeah, the clutch would slip, and it would never pick up the speed. You can never pick up the speed on the
couldn't
speed
load the
adjust.
machine.
Yeah, it would never load.
Yeah, you got to be over-greased.
Yeah. So we took everything apart and cleaned it all up. We told
It doesn't
everybody-
take very much on the gears.
No.
You know, I mean, it's a film,
Right.
basically just a little.
But
bitty
everybody, twice a month, squirting oil all over it. And then
That's normal is about just make sure they're clean, and then once a year is plenty.
Right.
Yeah, we take our pilot cage out every year.
Yep, that's a good idea. Clean the outside and the inside.
Yeah, that's what we do on our engines.
Do you take? How often do you change your bearings?
We don't touch the bearings unless there's a problem.
Okay, so when
Because when you replace those bearings, sometimes new bearings don't line up as good as the old bearings. We've got a magnet that we use for the bearings, but we haven't changed
yeah,
the bearings.
normal, they change these about every 5 years. Of course, I go to places for the outfit I used to work for that changed them only because we were there. They hadn't changed them in 15 years. You know?
This says, I think, the change would be 2 to 5 years or something like that.
Yeah, but you got to realize,
2 years,
We never change them, but we always check. We check
take them
in
out,
play.
check them, yeah.
yeah,
Check the in play and all that.
just like, did you see how I checked the bearing on that strap suspended ball head over there? You spin it, and then you can see the pole's magnetism suck it back at the end. It's a free bearing. What this does, if it gets to be, say you you had old bearings and they were starting to go bad, and your PMG started losing voltage, well then it can't drive it through that rough spot on the bearings, okay? So one of the biggest things on a Pelton that I always check every year, naturally on the PMG, I will go up with a 500 volt megger, and I'll make sure it's isolated with the insulation. Make sure it's isolated. You got few many megohms to clear there. You won't have any circulating current, so that's what saves your bearings in the PMG. The bearings will last a long time as long as you do that. Man, I have guys do it every year. We check the voltage and run that megger on it to make sure you're above ground, and then check the PMG voltage in the front. And it's always the same numbers. I think it's 27, 28, 29, something like that on the front of your cabinet. And check every one of those with a fluke to make sure that you have the proper voltage to the PMG. Now, normally all the Woodwards have a name tag on the PMG that shows loaded volts, unloaded volts. Unloaded volts means you had it on a bench, okay? Loaded volts is when it's hooked up to the machine. And it'll tell you the frequency. They don't put one on it, so you got to see what it is. So if it's normally, I always have it. The guy opens up the cabinet door, the pull-out door, and it's usually written
On the inside.
what it was, so you can see if it's deteriorating. Because when that gets, you can only be 20% low before you better start thinking about reshooting it. It'll go a lot farther. Normally a Pelton voltage is around 100 volts. Okay, so if you read yours and it's 75 to 100, it'll still run fairly well, unless you really get bad bearing. Okay, it gets down to 60s, it's going to start fooling around with you, and what it'll do is it'll be after a long outage is when you'll notice it, because it got cold and the coefficient of the copper in there, and you'll start it up and it'll hunt for a while. All of a sudden it'll just be rock solid again. It's because it warmed up. It took us a long time to figure it out, and then we got some hair dryers, and boom, it came right in right away. You know, and the voltage was around 66 volts. So we had to reshoot both those Pelton PMGs. They had been down. And the reason they get down is because when they take this apart to change the bearings and drop the motor out sometimes, somebody dinged up this, that drain, the way it goes in there, it has O-rings in it. Well, they left some rings out, and that oil was running down in the motor, and when the motor shorted out and burnt the motor up, it sucked that magnetism out of the PMG.
Bill's talked about remagnetizing stuff. The electricians do a lot of stuff I don't even know what they do.
Well, there's a way they can kind of boost it up, but a Pelton is a lot different than a Woodward. A Woodward is 3 10 kVA pots wound in a delta configuration, and you give it a couple seconds hit, and I mean, when it's on a bench, it always has, boom, it goes, and then you can put a variable speed drill on top of it, and just bring it up and see what your voltage read is in the unloaded position. It'll always read more on unloaded than loaded on the machine. Like a Pelton should read about 160 volts on a bench, but when you put it on the machine and run it, it'll be around 190, 100, right around in there when it's reshot. And the Pelton is designed where you can pull the rotor out without a tool, like, it's got magnetic keepers on the front of each one of the poles, where a Woodward, it's got to be all kept together, because once it goes clunk, you demagnetize it. So it's got on a Pelton, I'll try to find a Pelton rotor here, and I'll show you. It's just like an extra cover on the front of each one of the poles, And they have them in different configurations, 4, 6, 8, 12. And your book will show on your PMG how many poles you have on your particular unit. Sometimes, just like all manuals, sometimes they get a little generic and they'll just stick something in there that may not be exactly what you have. You know, it's just a picture of it for you to see. Is there any questions that you guys have on things that you've been working on that you?
One thing I did notice when we had the pilot and cage out, one of the guys been there several years, he said, always make sure you're moving that pilot up and down as you tighten those 4 screws on the bottom.
Yeah, that's what I was going to try to prove with this. They think they have a way to align this by dropping this down through there before you put the top together. See, I've always done it just the same way you did it. I'm not sure this will work, but what I do is I put this up in there and then I just snug the screws up and then I spin it around and I try to snug it up so I'm in there, because this is all, it's got oil running over it the whole time.
I mean, the cage is what you're moving up.
Yes, the cage is moving up and down. And that's the same as a Woodward. You always want to make sure that you can have good free on your relay valve. It comes up and down nice and free. Where a Woodward has 2 things that'll get in bad. You can have bad piston and bushing in the bottom, but you can also have there's no dowels in that condulet. And if you don't move that when you're tightening that condulet on a Woodward, it'll bind you up and you think, what the hell happened here? And I always said, well, I wonder if I didn't put dowels in that thing.
I was going to say, have you guys ever doweled?
I've never doweled them. I've always asked why don't you dowel them? But I had a guy who said, I'm froze up. So that's all it was. I told him, I said, well, did you move this the whole time you were snugging it? Because you got to kind of star it in, you know. It's only 4 bolts, but you still got to be gentle taking it in there so that it stays nice and straight. Because if the condulet is this high on that stroke, it doesn't take a heck of a lot out to bind it. Hardly any water noise on this unit, huh?
Quietest powerhouse
Yeah,
I've ever
no
been.
kidding.
Yes. Wasn't for those guys talking, huh?
Yeah.
We just had one of our vacuum breakers out. We thought it was hammering, and we didn't know if it was broken or whatever. It's got a piston in the dash pot built in. We've never done any maintenance on it. All we do is clean the grease out, you know.
It's just down off by the turbine wickets there, and you have it's a cam. What's it come in, like 30 to 70% gate or something like that usually?
Yeah, I can't remember. But
Yeah.
what happened is that oil that's in there mixed with the grease and water, and it formed a sludge, and it couldn't. The dash pot couldn't work, and it was hanging the valve open. It just hammered like crazy.
Yeah, but it's kind of sucked to
Yeah,
pop it
we
open.
took it all apart, put new seat in it, cleaned it all up, put the dash pot back.
Yeah, I imagine
together.
that seat was hammered pretty
Oh,
good,
no.
huh?
Well, it's a rubber seat, but there was
Painted
no
it.
physical damage to anything except the internal limiting pin when the arm sheared the pins.
Yeah.
And but now we're going to be pulling the rest of them apart and finding stuff that, you know, over the years, you know, they've reduced the crews, so they've reduced the preventive maintenance. And that was one of the things that they took off. They didn't think they had to do anymore. Well, all that sludge is built up, and so basically allowed that not to have a cushion like a shock absorber in the car. The shock wasn't working anymore. It's just bang, bang, bang. We thought for sure it was busted. It wasn't. But works. You can't even tell. You can't even hear work now.
Now you don't know whether it is working, huh?
Oh, we know it's working. But we got 7 more we got to do.
Yeah. It's funny how those things after, you know, we're blessed in hydro with big, slow-moving things that last a long time. You know, if there was more precision, we'd be breaking more stuff all the time. You know, kind of like a new car versus the old car. You know, when you can still work on it. Yeah, that's why I always like mechanical governors, because I've used parts that we've whittled out to make it work until we could get a new one. You know, take them down to the shop. You know, and most of the stuff in everybody's shop is the heads aren't exactly nice and straight like a new machine shop or anything. You know, everybody's worked on too many government projects. You guys don't do that though, I'm
Kind of
sure.
like your grandfather put a piece of leather in to replace a bearing on an old Model T or something.
Oh yeah, on the side of the road.
Yeah.
You know. Now we got to call 3A. Yeah, it's just like the old valves. I mean, all the leathers. You know, you're still having to go buy those, put them in neat's foot oil overnight so they'll be soft enough to bend, and it still works though. Well, we'll be gathering up for lunch here shortly, so. But if there's anything you think about, because we'll be calibrating and playing with this thing. And have you guys played with it yet to see how it moves and a little bit? Well, we can do some of that. We can come around here.
Calibration procedure.
Yeah, Glen Canyons.
Are you going to hand that out to us?
Yeah, I'm gonna have to have them print it. That's why I'm gonna have to. I'll get that.
Because we don't have one at my facility.
Oh, you don't have one at all?
No.
See, if you've got a Type B, I've got one. I've got several. All right, when I was still working for Pacific Gas and Electric Company, I made them for each plant. Well, each plant was a little different, and the guys wanted them written a little different so they could understand. Whoever was working on it said, well, why don't you say it this way? So there's no consistency in it, but the gist is the same, okay? Glen Canyons is a little bit more elaborate because they did it's 4 or 5 sheets and a bunch of pictures. Now I have that calibration procedure in here. It's just got to print out. We can kind of go over what we'll do after lunch.
The question is, why is there an adjustment at all? The reason there's an adjustment is because, what is that adjustment?
See, here's a calibration procedure. We can kind of read through it and kind of get a head start on. Naturally, you have to put, after the unit has been removed from service, the unit made ready to operate the wicket gates, and the appropriate clearances installed so the governor can be calibrated. Now this is head gate in, okay? It don't matter. Well, it's not. It still can be water in the spiral case, but depending on your configuration, unless you got a heck of a lot of tail water, but it won't move anything. That's what we want. Step 1, make sure the governor control gate limit is set for 0 position. So when we're talking about that, anytime you walk up to a governor and it's down and you're going to do something on it, you want to make damn sure you've got this thing where that gate can't move. I've seen it, guys calibrating it, and they've done something, they wanted to see the whole stroke, and then they come over and they're doing something else, and somebody gets pinched somewhere, in there. Where it's moving. You don't want to do that. You don't want to hurt anybody. You can't do any of this when anybody's working in the spiral case. It's got to be closed and locked, okay? So, or it's a lot quicker. So you're going to make that where nothing will move, okay? And shut down solenoid. Now we will block up. We will block up the shutdown solenoid. We'll cheat here, all right? You'll have to do it like you would normally do it. It's got a little block on it there. You just raise it up, all right? And then if you happen to have, this one doesn't have one, but if you happen to have the partial shutdown solenoid above that comes down to the top side of the T handle. You guys probably got that, okay? And then we'll go through a calibration, all right? So, step 2, transfer the governor valve to auxiliary valve. It'll be the first one we calibrate. We'll calibrate, see how the auxiliary valve is. Now, I'm never too picky on the auxiliary valve, because what's it for? It's for overspeeds and maintenance, to put the wickets in a position, just to stroke, maybe for air, for somebody's welding on a runner and you want air to go out the top, for ventilation or something. And if that's the case and he's in the runner, then you got to run the blocks on right where it is so nothing happens to pinch him, okay? Transfer the auxiliary valve, use the governor transfer valve control. That's here. And you'll notice almost all the Peltons different than the Woodwards. You have to pull out, go to the position, and go in. I've had a situation where I was doing testing on a unit, and brand new operators. He'd been from a Woodward governor place. So I said, well, prepare that thing, you know, get it ready for the governor. I want to warm it up, so go ahead and put it in governor control. And while we're eating, it's just about 8 o'clock at night, we were going to go in there and eat a steak. They brought it from the cookhouse, you know. I said, we'll warm this thing up. Well, he pulled it out and went from auxiliary valve control to governor control, didn't push it back in. So it never did the full transfer. So I said, well, go ahead and warm it up, because I don't want to do overspeed testing on cold bearings. So I said, go ahead and warm it up. So it took off, and I heard it take off. And the limits, you know, it doesn't care. It goes just as fast as this, and he had left, and this was all the way at 10, okay? So it's a 400 RPM unit, but I know for a fact it'll go about 728 RPM, all right? So it took off, and it's an impulse unit, so it doesn't take anything to roll it, it's in air, okay? So I scared the hell out of him. The desk is here, and the control board was there. I jumped over the top of the desk and reached between his legs and hit the 86E, and then to get to the governor, I have to go down another deck. So I'm hauling ass, because it's the only thing you can stop it with is the deflectors. Well, the deflectors just stay right where they are in auxiliary valve. They don't care about deflectors. Those are for upsets and shutdowns, all right? So they're just out to the side. So when I got down there was a guy kind of in front of the governor cabinet, and I reached around him, and I just touched that, and it, boom, I could hear the deflectors come in, and it started, stop that water. It took about 25 minutes to slow down to stop, but when you go that 108, you know, when you go over 150% of speed, it's not a good thing on a generator. When I was there, anytime we went 150 or more over speed, it was time to maybe pull a little iron and check keys and the poles and do a good inspection on the machine, because those speeds, there's a lot of G's out there, you know. The big units, 500 G's out there on the outside. What's the speed of your units?
81.8.
Okay, so they're slow speed machines. You got about, 80 poles?
Oh, I couldn't tell you.
Well, what was it? How much?
81.8.
81.8 RPM? Show you how to do that. Any 60 cycle system, all you need to know is how many poles or what the speed is. All right, so you go 7,200 divided by, what do you say, 81 and a half?
81.8.
81, oops, 7,200 divided by 81.8 equals, you got 88 poles. Okay, it'll work either way. So you got 88 poles. So I go 7,200 divided by 88, 81.8. Okay, so any 60 cycle system, 7,200, divide the speed into it, that's how many poles you got on the unit. The more poles there is, the slower the unit. Okay, steam units, 3,600 RPM. So you go, well, what the heck would that be? So you go 7,200 divided by 3,600. 2 poles. That's all they have. Okay? It'll work every time. Unless you push the wrong button like I did the first time.
Entry level 4, so I had a year learning out. And that's only because I didn't have any damage.
Now, you guys are a lot of USBR? Anybody? So, they calibrate the main valve first. That just tells me they don't, just like me, they don't, the auxiliary valve's not a big concern to be calibrated right on.
You don't get the auxiliary valve first.
That's why we do it that way on a Woodward. We do the auxiliary valve first, and it
Do the main valve first, and you come back to the auxiliary valve. You're going to be doing a lot of
you make changes, you're going to have to do things twice sometimes, okay? And it's just, I've asked several guys, you know, why do you do it that way? It's mainly because they've always done it that way, okay? Which is a lot in hydro.
Well, our book tells us to do this.
Yeah. And this is showing a picture of the gauges and everything. This is the Type B cabinet, probably just like you got, okay? And you can see the little stacks of limit switches will be in here, huh? Usually running out this way for your cams. Showing picture 2 is all right. Step 3, once the governor's been successfully transferred to the auxiliary valve, operate the governor shutdown control to the reset position. See picture 3. This picture just doesn't do me any justice at all here. I don't. But if you go and read it again, shutdown to the reset position.
I noticed it didn't say to set your speed adjust to 0.
Once it gets to when you're going to set the speed on the unit, it's kind of the final thing you do anyway.
We set our speed adjust to 0 right off the bat.
Okay. It was on the last one? The gate limit control is set for 0 position. Yeah, I didn't think it said it, speed adjust. Because that part really, until you set the actual speed of the unit at zero droop. Now have you guys set have you seen any change on your Peltons if you set it with the droop at 5 or the droop at 0? Okay. Well, normally, like on a Woodward unit, all right, if I was going to set the speed on a unit, which is have to take the little locking nut out. This one doesn't have a locking nut on it, by the way. It's just the one down below. Okay, so if I was going to set this, I would bring this to 100%. I would move my droop to 0. I would have field on the unit, and I would set that speed.
Really?
Okay?
We always did it at 5%.
All right. All that means is, and that's USBR, that's what they do. The core, but the core does the same thing. And it's all that does is change. You know how you saw the droop curve in the class? Instead of pivoting at 50%, it pivots at 10%, speed no load. Now, the reason they do that makes good sense to me. It's the only thing that counts is from there up, is what they're saying, you know. But all it does is it doesn't make a few things linear. The unit still works fine. It still does its thing. Lots of people do it this
you're
way right here when they set the speed.
And by doing it that way, you'll get out of whack at 50%. Is that what you're saying?
Yeah, but you won't see it on any of the reaction of the machine. It works fine. That's the way you guys do yours to it. Set it.
We go 0 and 100%.
Okay, and that's
how
all that does is it means that the droop curve pivots at 50%. When you do it with 5% on the machine, it pivots at speed no load. Pivots right where you are. Okay? And it makes it what it does is yours probably go from somewhere in here this way to load the machine. When he does it, it's in the hole and he splits it over the span. That's the
When
difference.
our machine starts up, it's to the minus.
It is? Well, it's just because they probably set that to the minus
Well, it's
Just-
automatic. I mean,
when they run it back.
down, it automatically runs it back down
Yeah.
before it disconnects.
Now, when they go out to start the machine, does the operator go out and raise it up, or he just starts it and then lets the auto sync?
Yep,
Step
you
it up.
just hit start. Unless we got one unit that's been giving them a little trouble, they've had to go do a manual sync on it.
Yeah, well, that's because it's hunting around a little bit.
Yeah,
Okay, but
yeah, because
you know that's what an auto sync's doing. It's just giving signals. It's giving signals in here, and the farther it is away from speed, the bigger the signals and the faster the pulses. Okay, until it gets it close, and then the closer it gets, the smaller the duration and the smaller the pulse, the time pulse. So it'll just comes in there real slow and it gets a good scope, better than a 7-second scope. Most auto syncs will grab it and paralyze it. But that's the only difference in setting it from 0 to 5, is the pivot point of the droop curve. Okay. I've seen some that it didn't make any difference on a Pelton. You know, and Jerry and I thought, he said, oh yeah, it always makes a difference. And I showed him one. I did it both ways and it didn't. He said, well, the droop must be off. Hey, it could be. But when it's online, I'm seeing 20% with one turn of the speed adjust. So that tells me, that's the true calibration of droop for me, is rather than calibrate it in the dry, I just watch it go online, make sure that I've got the response that you know, when I start the unit up, when the guy starts the unit up and he's up there and he's parallel and he's got about a megawatt on it, I said, hey, you mind if I just go down there? And I gave one turn on it and make sure it goes from 18 to 22% gate. Then I know. Sometimes he lets me do it on both sides so I can see if it's balanced, because there'll be a little difference one side or the other. When you guys close your gates, do you set it at 0? When your gates close all the way, is it on 0 or is it below 0? Okay, and that was the old Woodward used to be, you did it below 0, all right? Well, I was with Jerry, and I said, well, I've always put it, like the book says, below 0. And he goes, he's thinking all the time, all right? So he started thinking about how much it could be off on droop. So we argued for 3 days, you know, going back and forth to work. And I said, explain that again. And I went down there and I tried a couple things he said to try, and I'll be damned if he wasn't right. Boy, I hate that. But he was right. And what it does is, you got a span from 0 to 100. That's all the governor cares about, 0 to 100. So if you've got 4 in a hole, all the way to 100, that's not 0 to 100. All right, that's too big a span. Most of the time on these, if you're 4 in a hole down here, you load the machine. You guys never see it go to 100. You see it go to.
We don't let our units go to 100 because they're set at 92 because.
That's right. And all you've done is you're putting the squeeze below 0. It wouldn't matter if you left the squeeze at 0. Now you'll have to readjust your limit switches because you won't be able to roll it off. Okay, but if you had the squeeze down here, and then when you shut the pumps off and let it sit overnight, it would come up to whatever you are below that. It's the same old thing, but you would have to readjust the limits if you made that change. It won't change the operation of the governor any. Okay, but that's the reason. First of all, from about 86, from about 76 to 86, is about as high as you'll ever see on these units at full load, because the rest of this is if you had a real low head. You know,
We run about 82.
yeah, and that's full load. You know, I went to, I believe it was for the Corps, Boyson Reservoir, and I asked him, I said, why are you running 100% gate? And that's the big difference. I was in a utility business, he's in the water business, all right? He's got to deliver so much water down the Wind River out of that lake every day, and it goes at 100% gate. And I said, you know, you're sacrificing cavitation on that runner for delivering that water. You know, if you, in fact, I had to prove it to him, you know. He says, well, yeah, but I said, I don't want to lose my megawatts. I said, you mind if I play with it a second? He says, no, go ahead. So I took the gate position. I took that baby down to about 86. Never lost a megawatt. So all that other water is just taking metal and stuff away, that's all. But he was running, he could run more cubic feet a second down the river. Gravity's a great thing, huh? God and gravity keep us employed. But it didn't make any difference. When they were talking about gate effective timing, okay, so you would sit here. Well, let me give you. Well, that's loose, isn't it? So you'd have your stopwatch. So you drop out your shutdown solenoid, okay? And when it hits 75, you start your stopwatch, and you hit it again at 25, and you would double that. And that's gate effective timing. That's the only reason, because you're gonna get a little different time differential once you hit the cushion of the servo. And that's all it's doing, is putting it there. Like, well, that's where your limit goes to. Your preset on your partial shutdown solenoid. Yeah. Okay. So when it first starts, the actual no, it's off that rod that comes down to the top of the T-bar. Yeah. That solenoid there. Oh. Okay. So what it does is I'm going to use the red hand for the demonstration. Okay. So you're sitting here going, you hit the start button, you got your cooling water on, you're going to go. It goes. Now the speed starts coming up and everything. And then this hand's going up, all right? Now you're almost to rated speed. The governor grabs it, and this comes down to about 10 and sits there wherever that speed no load is. It sits there, and then when you parallel the unit, this goes out of the way. The limit goes out of the way. Well, I got to tighten up that shutdown so it's all loose in the back and it's not working. All right, guys, they better get